Hi, Mohammed. I was talking just now that if you can go ahead, go to the hands-on folder for today's practice and open the Word document and the Excel. And you may also download the rest of these documents. We will run SPSS at the end. So all of them will be needed.
Thank you so much.
Okay, so let's open the Word document and the Excel. And I'm going to share my screen here. Can y'all see my screen well? The Word document here? Okay, great. We will work on non-parametric tests today. And these are the tests different from the rest of these that we have been working on, mainly because they are the ones don't have that many assumptions in terms of what kind of distributions the data should be or should not violating these assumptions. For example, normality. Like before, a lot of these tests we had, for example, the independent sample t-test, we have this normality assumption. We assume that these independent samples, they are from normal distributions. That means they should not be violating normality. And other assumptions like homogeneity of variance, and also like linearity. And so these are assumptions for many of the tests we've been working on before. But these ones we are going to do today, they are much flexible as long as you have at least ordinal level data. Ordinal means you all remember, right? The measurement scale. At least these numbers or these responses, they have difference in terms of order. Okay, so ordinal, interval, ratio, all of these will definitely be fine, but categorical, no, because it will, but not for our test today we are going to work on, but for some other tests. Okay. All right. Let's just dive in here. And just in case that I forgot, today is our last hands-on meeting. So we won't have an official hands-on meeting next week or starting from next week. But next week, Dr. E is planning to have one-on-one meeting with y'all if you need anything. And she will send you all email about these available time slots, and you will select the ones that will work for you. Okay, just make sure that you pay attention to the email. Okay, I think someone just joined in. To whoever who just joined in, I was talking that today will be the last meeting, the hands-on meeting. And next week, Dr. Yu will send you all time slots that you can choose to meet with her one-on-one. Just pay attention to her email. And today we will work on non-parametric test. If you can go ahead, go to the hands-on folder, open the document. Okay, let me ask you, some of you, to read the question for me. Morgan, can you help us read the question 1 here?
Question 1, is there any significant difference in depression between two recreational drugs, those who took alcohol versus those who took ecstasy?
Okay, very good. Thank you so much. So this is our research question, basically. Now, with this specific research question, can you tell me what the independent variable and the dependent variable, what they are they? First, dependent variable, what is it?
Would the dependent variable be the level of depression?
Yes, do y'all agree?
Yes.
Okay, very good. So it will be level of depression. Let me remove my, okay. It says depression, basically it's level of depression, how we measure it, right? What is the independent variable? Can I have a volunteer to share with us?
Recreational drugs.
Recreational drugs. So these two, thank you. And these two drugs, okay. And what would be the null hypothesis? Can I have a volunteer?
Would it be that there's no difference between the depression level of people who use those two different recreational drugs?
Yes. Who's this talking just now? If you don't mind, because I only see.
Hi, it's
Oh,
Erin.
Erin. Okay, great.
Yeah. Hi.
Yeah, since your Zoom name is not it's not your name, so I was wondering.
Yeah, I don't know why it's like that.
Yeah, never mind. Thank you so much.
Uh-huh.
And that's exactly, so I'm just going to move it here. So there's no significant difference in terms of depression between these two drugs. And then, so what we are going to do today is we will try to use this, one is called Mann-Whitney U test, or it's also called Wilcoxon-Rank sum test. Okay. What we will do is we will find we will calculate it in the Excel sheet, and then we will make a decision. And here, this is we can come back to this, and so there's something special about this here. Okay. Okay, let's go to the Excel. Not this. This. Okay. Actually, this is the work one. I need the not worked one. Okay. All right. Okay, so this is our data. And this is how the data looked like originally. So here in the yellow highlighted part, it's the drug 1, and here's drug 2, and here are the names of the drugs here. And then here it tests the BDI. BDI is the survey, or is the instrument test the depression level. Okay, so here it tests the depression level on Sundays. This is a one variable specific on Sunday, and this is another one on Wednesday. So different days. That means these are two dependent variables, because one is on Sunday, another one is on Wednesday. Okay, and see if they are different between the two groups. Okay, so what we will do here is we copy this data. We copy the data here. That's what we did already. So you've already have this done. So what we are going to do next is we will rank all of them. So how do we rank all of them? So smaller depression level will go first, right? So what I will do is I'll just go highlight the rows. Maybe I'll just highlight these two rows. There's two sections, not all of them. So highlight this area, and I'm going to sort. I'm going to go data and sort. This way, it will sort both columns all together. Like sort based on the BDI, because that's the one that I want to sort and rank. Okay, you will see how it looks like. Now it's from smallest to largest. See, this is 13 is the smallest and 35 is largest. And all of these, the two columns, they change at the same time in terms of their rank. So now what I will do is I will just rank them. Start from 1, 2, 3. Okay, 1, 2. And I'll just drag this. Drag will give me all these ranks directly. So now we have exactly 20 of these data points. So rank 20. However, this specific test, what they do when they have tied scores, like 13, we have 2 of them, they give an average rank. So instead of being 1, 2, they are different. So both of these 13 will get 1.5, which is halfway between 1 and 2. So we will make all of these tied scores be the average of their rank, and the rest of these will keep the same. Okay, so we will do this. 13 and 13, they are tied, so we will just give them average of 1 and 2, which is 1.5. So these two are 1.5 because here we have 2 tied score, 1 and 2. Okay, and then we keep going. 3 is good, 4 is good. Oh no, actually 4 is not. 4, starting from 4, we have 15. How many times? We have 3 15s. We have 1, 2, 3 here. And that is corresponding to 4, 5, 6, these ranks. And what's the average of 4, 5, 6? 5, right? So because 5 is in the middle, so I'm just going to, instead of writing 4 for all 15s, I'll just write 5. So for all the tied scores, I will use the average rank of them, of these specific scores. Okay. And now 16, we also have tied ones. 16, we have 1, 2, 3, 4. We have 4, and it's 7, 8, 9, 10. So the middle point between 7, 8, 9, 10 would be between halfway between 8 and 9, which is 8.5. So I'm just going to write 8.5, 8.5, 8.5, and 8.5. Okay. And 17, there is only 1. So I'll just keep the original rank. And 18, there's quite many. Let's see, there's 1, 2, 3. So I can just use this, since there's only 3, I can use the middle one. Rank is 12, 13, 14. The middle point of the rank is 13. So I just use 13, 13, 13. And there are 2 19s, 19 and 19, 2 of them. So the middle point between 15 and 16 would be 15.5. So 2 of these will be 15.5, the adjusted rank. And for the 20s, we have 2. So same here, middle point of 17 and 18, 17.5. For the 27, we only have 1, so it will be just 19. And 35, we also only have 1, so the rank keeps the same as the first time we rank them. Okay, now after ranking them, here the gray box, which already summed it for us. So if you highlight, you see it's the sum of I2 to I21, which is exactly the new rank we just gave there. Okay. So with that being said, you see that this Mann-Whitney U test is based on ranks. Okay. Okay. Here are the actually we also need to calculate the rank for the first drug and the rank for the second drug. That's what we need to do next. So after doing that, I'm going to highlight all of these, the whole area, and I will organize it back to the two drug organization. Okay, I can do that by go sort again. And this time I'll sort by drug. This will give us 1 first, 2 second. Okay. So now these ranks, like all of these ranks are for first drug, and all these ranks are for second drug. Okay. Okay. And then since this is a sum of group 1, so basically, if you highlight, you see it's exactly sum of the group 1. And then the green here is the sum of group 2. And these are already made it ready for us, but you know what they are corresponding to. Okay. Okay. And let's work on this second one. And you go ahead, work along with me together. These are 2 tests, but yeah, we will just we'll work them together. So the first thing we will do is what? Rank them, right? So select the 2 column and then go sort by the dependent variable, which is BDI, smallest to largest. Okay. And now do this again. See, this is we can tell this group is almost the division is clear, more clear than the other one, because you see most of these greens are here, are smaller ranks. So let's just rank them again. And you can highlight, and here's the left. On the right, there's little point. When you hover over there, there's a cross, and you can drag. This will give you all these continuous numbers, which is what we want because we want to rank them. So 1, 2, 3, 4, all the way to 20. Okay, and now the new rank will check all the tied ranks. Not all the tied scores. All the tied scores, they need to be adjusted in terms of their rank. So we can just go continue. The first one, no tie. Second one, fine. Third one, yes, we have 2, 6. So use middle point, 3.5. 3.5. The next 7, that's fine. We don't have tie. 8, that's fine. 9, that's fine. 10, that's fine. So keep the scores if they are not tied. Next one is also fine. Next one is also fine. Next one, good. Next one, good. This one is also good. 30 is also good. 32. 35 is not. 35, we have several tied scores, okay? So this is 1, 2, 3. So we have 3 tied 35. So we will use the middle rank for that 35, which is 17 here. So we use 17, 17, 17. And 36, that's fine. 38 or 39, that's the only one left, so we'll be fine. Okay. Now we have another score here. And then we will also calculate the group scores again. Okay. And then you again highlight. If you highlight the whole section, what it does is when it go sort, it will sort all of these all together as a row, not just single cell. So that's why we highlight the whole part. Go by drug, small to largest. Okay, now it's sorted for us already. And now if you take a look at the sum of group 1, that's correct. That's exactly sum of group 1 for the ranks. Okay. And same here for the group 2. That's exactly the same sum of the ranks. Okay. Okay. After we have this sum of ranks, then we can calculate it. Okay. So that means we've finished all first 4 steps here. And all we left is to calculate the Mann-Whitney U test. Okay. The N1, N2, they are the number of observations in each group. In this case, number of these drugs. So drug 1, we have 10. If you see here, it's 2 from 11, so it's 10. And drug 2, we also have 10. It's from 12 to 21. Okay, so what we can do is you can follow this formula to calculate 10 times 10 plus, now N1 is also 10. 10 times 10 plus 1 divided by 2. Subtract R1. R1 here will be the sum of the ranks. Okay, I'm showing you here the calculation. This 100 is 10 times 10 plus this middle part, 10 times 11 divided by 2. Subtract R1 is which is the sum of the ranks, which is the first group. Okay. So the one we calculated here is 119.5. So we subtract 119.5. Okay. And that will give us the score, which will give us 35.5. Okay. And if we calculate the second one on Wednesday, test on Wednesday, will be the same. 10 times 10 plus 10 times 10 plus 1, which is 11, divided by 2. Subtract R1 here again is the sum of the rank for the group 1. Okay. And now this gives us 4. And after having this U test score, we can go back, just like now when we have this score, we can do, what we can do is just similar to what we've been working on before. And there's critical score. In this Word document, we brought it. And now I transferred these 2 results here. One thing that's special about the Mann-Whitney U test is if your obtained value here, this is highlighted in red, obtained value is less than the critical value, then you will reject the null hypothesis. Did you all see this? Is it different? It's actually different from what we've been used to. Usually, it's when we have a larger value than the critical, then we reject. Okay, that's when we were working on, for example, independent sample t-test. Okay, but regardless, this is just a way that people who who worked out these tests, and they resulted this. So we go ahead and look for the critical value. So when this in the appendix we provided the table when the sample size is less than 20, and our sample size is less than 20. So we go and find the critical value. Okay, let's go together. This is a little bit small. Let me make it bigger. Okay. We will just go 10, 10, okay, because we have 10 in each group. So 10, 10 is somewhere here, here. Okay, here. This is 10, 10, right? Go across 10, go down to the 10 to find the 10, then locate where it is. So it's 23, okay? Just going to zoom out. So we just resulted that this critical value is 23. If it's 23, based on the given obtained value is less than critical value, then we will make a decision. So now for Sunday, the depression level, is it significant? Or are we going to reject or accept first?
Sorry, I didn't understand. Where did you come up with a 10-10?
Oh, you don't have the appendix? You scroll all the way down to the Word document?
Yeah, I know that one, but where did you get the number 10 and 10?
Oh, do you have this table?
Yes.
Okay, you maybe it will help you if you go zoom in and then you go see we have N1 and N2. In our case, N1 is equal to N2. Both of them are 10. Like we have drug 1, we have 10 observations. You have 10 participants, right? For example, and drug 2, we have 10 participants.
Right, okay.
So you would just go 10 and then go down to find 10. Yeah, this is how. Okay. All right. So now we can make a decision, right? When this is greater than 23, what's our decision? Reject or fail to reject? This is tricky.
Fail to reject. No?
Fail to reject is, do y'all agree? Okay, good. So since this is greater, based on this condition, we will fail to reject, right? So what about this one? Wednesday's depression level.
Reject the null hypothesis.
Reject the null, okay? And if I further ask, what does it mean, reject the null?
There's a significant difference.
Very good, okay. There is significant difference. And if you recall, when we sorted the ranks, and actually the second one, which is Wednesday, the Wednesday depression level, they are more distinct. Like the green and the yellow, they are not, they are more distinct after we rank them. Like the greens are on the top, even though we ranked them. So, and based on that, like based on the observation, you can even tell they are more different compared to the Sunday one. So we reject the null hypothesis for that. And then further we conclude for Wednesday, we have a significant difference. However, for Sunday, we don't have a significant difference. Okay. All right, let's continue with the second research question. If you just to wrap up, if you take a look at this, and I talked about the assumptions. and we will check them when we get to the SPSS. This is similar to what in terms of the test that we have learned before. It's also two groups if you take a look, right? So this is a similar, or if you have to find a counterpart in those tests we have learned, it would be similar to, or the counterpart is independent sample t-test, which we also have two groups. But in that, we were examining if the mean from each group, they are significantly different from each other. And in that, we have all of these assumptions: normality, linearity, homogeneity, variance. Okay. All right, let's continue. For question 2, can I have a volunteer to read the question 2 for us, please?
I can go. Is
Okay,
there any
thank you.
significant difference in the sperm counts by the number of soya meals?
Okay, thank you so much, Iman. So based on this research question, interesting. I thought it's interesting. It seems like the author, because these are from the textbook, the author, they did this study themselves. So anyway, what is the dependent variable? Can some of you tell me?
Soya meal.
Dependent variable, it will be something
So
like
soya meals, I think, is dependent, and independent is the sperm counts, right?
Dependent is the one that you're
Yeah.
really measuring and testing the differences, and in terms of, yeah.
Yeah, the sperm count is dependent.
So yeah, exactly. Sperm count will be dependent variable. Okay. And then, like Iman talked about, the meals. The meals will be independent variable. And there are 4 of these if you see, like no meal. I forgot one probably is like basically number of meals different. 1 is less, and 7 is the most, have the soy meal the most. Okay, what would be the no hypothesis?
So there is no significant difference between the sperm count and number of the soya meals.
Yeah, among this number of soy meals. Exactly. Okay. There's no significant difference in sperm counts by number of soy meals. Okay. Next, this is a new test called Kruskal-Wallis. I think it's a little bit difficult to say. Anyway, so this is how it's tested, or it's calculated. And we will work on this in the Excel sheet. Okay, so let's go back to the Excel, the one that we just worked on. And let's go to the second tab, Kruskal-Wallis here. Okay, very similar. And you see that the only difference that this research question from the first one is this one, we have 4 groups. Because 0 meal, 1 meal, 2 meal, 4 and 7 meal. Anyway, we have 4 groups comparing. Okay. So what we will do here is very similar. We will first rank them. Okay. And the good thing is all of these are different, so we don't need to adjust the ranks. Okay. So you can go down, see we have 4, 1 group, 2 group, 3 group, and 4 group. Okay. And then the second column is the sperm count. So in each group, okay. And now we will do is we will rank them. So similarly, and now since I don't have anything below that, I'm just going to select the whole 2 columns and then rank them. Again, select them all together because you want to have the information associated to your ranks, the group information. So go and then sperm count and then smallest to largest. Okay. So we rank all the way. We actually have 80 of them. Okay. 20 in each group. So we just rank all of them. If you take a look, none of these are really, if you take detailed look, see if they are, none of these are repeated. Okay. So I'm just going to okay. And that's 80 of them from 1 to 80. Okay. And none of these are repeated, like I said. Okay. And now, similarly, remember we are checking how these groups are different in terms of the rank, and then sum the rank for each group. So we need to go back to the group organization. So we will just select all of these columns and then go sort and then go, this is soya, yeah. That's the group variable name here, okay? Small to largest. Okay, now it organized in a way that we start from the group 1, 2, 3, 4. Okay, now if you see here on the side, there's a little sum already created for you. If you see, this is exactly the sum of group 1. So we find the sum of all groups. Here is the sum of group 1. Okay. Just want to let you see. If you go down, oops. Here's the sum of the group 2. And this is the group 3. You can double check by double click and make sure. And here is the group 4. Okay, that's exactly right. Okay, so now once we have the sum of these ranks from different groups, this again, the sum of the rank represent the R. The R notation is corresponding to the sum of the rank. So basically R is each of these 4 score. Okay, Rn is the total observation we have. We have 80 together, all together 80. Okay, so the first part is this, to calculate the age. Okay, it will be 12 divided by n times n plus 1, which is 12 divided by n, which is 80, times n plus 1, 81. Okay, so you can just write equals to, and then I am just going to, since I have it here, I'm just going to copy and then equal and paste. Oh, something wrong. Okay, yeah, fair enough. Okay, now calculate the first part. Let's calculate the second part, which is the sum of each rank sum, each group rank sum squared divided by n. So that means I'm going to add all of these equal to square this sum and divide by n. This n is small n, which is the size of each group. And the size of each group here is 20. So divide by 20. Okay. And maybe let's add a parenthesis here so that we can do the summation all together. This is the first one. We have 4 groups. So add another parenthesis, which is the second one, will be this one squared. You can see it here as well, squared. And then divide by 20 and close parenthesis, and plus the third one, this one, and then go square and divide by 20 again and close parenthesis and add, which is the last component, this one squared and then divide by 20 and close parenthesis. And now you see it's basically the sum of the first group's rank sum squared divided by 20 plus second group rank sum squared divided by 20 plus the third group rank squared divided by 20 plus the last group. Okay. If we hit enter, we will get this result. Okay. If it's too long, sometimes if it's too long that you think it's easy to make mistakes, just separate them, like calculate each one, each group with the r squared divided by n, and then add these 4 after, like make it 2 steps. Okay, the last one is equal to 3 times n, which is 80. This large n is all observations plus 1. Okay. Now, what this does, it automatically create this for us. But what we can do is basically use this one times this one and times this one, because it's product of these 3 parts. Oh, actually, subtract the last one. I'm sorry. Subtract 3. So subtract the last one. In my case, I7 times K7, subtract M7. Okay. Any questions? Okay. If not, here is a table also that I found. You can go ahead and open it. So that you can check this quickly, check the critical value. So I'm going to go back to our, so we calculated the H score just now, which is 8.65. Okay. And then what we need to do is we need to find the degrees of freedom here as the number of groups, subtract 1, which is we have 4 groups, 4 subtract 1 is 3. The critical value here, it's 7.81, but we can look this together here. That's a website that I found that has the critical value already. So when sample size greater than equal to 5, we can go find the degrees of freedom, which is 3. Significance level, we select usually 0.05 or 5%. So it's corresponding to 7.815. Okay, so that's 7.81. We just used a 2 decimal place. So this will be normal, which is when the test score is greater than the critical value, then we reject the null hypothesis. That's why this is not specially noted for us. So in this case, H, which is 8.65, is indeed greater than the critical value. So what are we going to do?
Reject the null hypothesis.
So we reject, yes, we reject the null hypothesis. And like all other tests, when we reject the null hypothesis, what does that mean? Do we have difference among these groups in terms of sperm counts?
Yes, it means that there is a statistical difference between each group.
Okay, very good. All right, thank you all. And let's go to the SPSS document. And you go ahead and open this SPSS document. It looks like it takes a while to open. I don't know if recording makes it slower. Mine is still opening. Oh, here we go. It does take longer, I think, than usual. Okay. All right. Here's the data set. If you take a look at this is exactly the same as our data set. This part. Okay. It's 28, 35, 35. Yeah, that's two columns. Yeah, the Wednesday is this. Okay. So let's just check this. Okay. What I will do is I will go ahead and first do the analysis first. So let's go analyze, go non-parametric. Remember, these are non-parametric. And go to independent sample. And these are independent sample. That means these groups are like whoever take the drug 1 and the drug 2, they are independent. Like they are not the same participants, for example, right? Okay. Oh, here we go. And then we go, actually, let's see if I clicked there. I'll go legacy dialog. I'm sorry. They are independent, but here are more specific. We have 2 independent samples. So we go 2 independent sample. Okay, select this. The other will work too, but this is a more direct. So I am just going to select both of these. Since we have 2, you don't have to, you can do one by one, but you know, since they are the same dependent variable in terms of their grouping. Okay, and after you click the drag to the grouping variable, you will have to define the groups. By defining, you basically enter whatever numbers you used to as values for these groups. So we have 1, 2 here. Okay, so I'll click OK. So here the default is Mann-Whitney U test. So we will keep that the same. I think options is basically descriptive. This goes to my We can select descriptive here, but we actually don't need it for now. So I'm just going to, if you can, it won't hurt anyway. So just click and then go OK. Okay, here we go. So the Mann-Whitney test, after you run it, you will see, and here is the descriptive. We do have 20 total observation, 10 in each. This is not from descriptive, we didn't know, but from the test, we know each group has 10. Okay. And here are here's the sum of rank, which is the same as we just calculated. But here's the test result. Okay. And now for the Sunday depression level test, we have the U. And here it reports the U is 35.5. If you take a look, it's the same as what we did. We calculated here. And for Wednesday, it's 4. So that's the same as we calculated. But what it does is it's actually converting to a test here. Okay, this is Z. And then we can have this significance testing. And basically what we are looking at here is this significance, which is the exact sig. This means p-value. And by having this p-value, you are able to make rejection or fail to reject decision. Like when the p-value is greater than 0.05, that's quite large probability, right? So we fail to reject. However, here, this is very small, 0.00, even smaller than 0.001. So it's very small probability, less than 0.05. 0.05 is alpha, is also the significance level. Then that means we reject. And that's consistent with our conclusion in hand calculation. But what the testing does is it provides the p-value directly instead of the critical value, and then compare this U with critical value. This is more straightforward, basically. Okay. All right. So having this, we can go ahead and do. You can go ahead and take a look at this description. How. Yeah, my screen is slow now. Here I have a description. Actually, we need to run another thing for the write-up. I know it's a little bit small. We need this. When writing this up, we need to have the medians, usually report medians, okay? And then we also report the U. The key things, see, we need to report the statistics. And some of y'all, you don't report the statistics in write-up. That will be totally inappropriate, because if you are making decision, you will need to provide evidence, okay? So these are what we just saw from the report, okay? And same here. Okay, you basically write this conclusion, and then also provide these medians. So I'm just going to now go ahead and opening this document at the same time. We can go ahead, analyze, and go descriptive statistics, and explore, and then we actually need a descriptive for each group. So sorry. So we need to first view the data by split file. This is a little bit more, but that's fine. Organize output by groups. This way we can find the median by each group, not because we listed the drug as one variable. whenever it will report the whole thing, the whole column. Okay, so by doing this split, we can basically separate by groups. So only drug 1 and drug 2 will be reported. Okay, so now let's go and descriptive statistics, and let's go explore, and then select these two, and then statistics. Actually, I think it's this will give us mean, but I think it's another, not plot. Sorry, let me see which one give us descriptive. Did I say descriptive, or it's actually from explore then? Anyways, I can't find where the medians are. I will find it just in a minute, but let's go ahead and run the other one first, the main test. So basically what I was saying, that in reporting, we also need to provide some specific statistics, and reporting median, sometimes mean, but mostly median for Mann-Whitney U test is a common thing. So anyway, let's run the other test, okay, with the 4 groups. Let's go analyze a non-parametric test, a legacy. And now instead of 2, it's going to be more than 2. So we'll go K independent samples. And then let's select the dependent variable, which is what we are testing, sperm count, to the test variable list, and grouping will be the first one. And now if you take a look, our groups are grouped by 1, 2, 3, 4. So same thing, divide the range. So it will be 1 to 4, minimum 1, maximum 4. Okay. Options. We can have descriptive if we want to. The descriptive, again, it provides mean, not here it provides median though. Just click the median as well. Okay, let's go click OK. Okay. And now this is the result for the Kruskal-Wallis test. And you see we have 80. And this is, they are descriptive statistics. And each group we have 20, 20, 20, 20. And here is the key statistic. We have Kruskal-Wallis, H test is 8.65. This is consistent with what we calculated. And here again, the sig is often the part that we need to look at. Now, the significance, again, is the p-value, is 0.034. Say our alpha, which is the cutoff probability, is 0.05. In this case, we are 0.03 is smaller than 0.05. That means it's very small probability. So we reject the null hypothesis in this case. So basically, this is how we look at that. And then here it provides us the median for each of these groups. Okay. Actually, we don't need the median test. I thought it provides us the median. Anyway, we don't need to check the median at all. So this is already enough. Let's come back. So basically, we had the test. And here, for the Kruskal-Wallis test, we just need to report the age with the 3 here inside is the degrees of freedom. It's the number of groups, subtract 1, which is 4 subtract 1 in our case, and report the p-value. In terms of the medians, let's see. Okay, you can report mean too. Either one will be fine. I'm just thinking to find the median for you, but I somehow I missed it somewhere. So what we will do here, here it talks about, I'm just going to let you take a look the assumption, okay? For example, it talks about check normality, linearity, and these things are related because if your data is already normal and met these assumptions, then you should go ahead and do this independent sample t-test or the ANOVA test, which is corresponding to the Kruskal-Wallis test, okay? However, the reason we are doing this is because they violate some of these assumptions, okay? And I'm going to show you how you can check these assumptions. And I think my data is already splitted. Just want to make sure it's not. Yeah, it's not. Okay, I'm going to split again. Okay, the reason I'm splitting is I'm going to check if each group is normal and the variance is the same. Let's check the normality, for example. To check normality, you can go to, I think, Explore will give us, not this one, let's just go to the first one. Yeah, I think I split it, this one. Yeah, this is split it. Okay. Somehow I can't find it. Something changed, or anyway, maybe I can record the how you can check the linearity, mainly the normality, and find the medians in the last portion of the video. Okay. Since the time is already here, I'm just going to let you all go if so for looking for the median, first to make sure, since we are looking for median for each group, make sure that it's splitted, like split file. And yes, it is. So I just make sure that, and then go analyze. If we go compare means, and then select, since we need to have both of their medians, so select 2 of these variables. And we don't need mean or this, so we just put them back. We can select these all by go shift, and then we need a median. So I'll just click median. And if we want to, we can go test for linearity. This is also one thing that we tested, the assumption. Okay. 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 Now, you see that the median for, we should have two. Yeah, here. This is one group with drug of alcohol. And remember, these are splitted. This is why we need to split first. So when it reports each one, each group. So now this is the first drug. And then we have median for Sunday is 17.5. For Wednesday, it's 33.5. Okay. So basically, I'm going to show you here how that should look like in the report. Like in the report, APA, when you write median, you write MDN, just like this one here. Okay, this represent median. Okay, and then you write the group. So for these drug user, we have Sunday. Of course, this is talking about Sunday, I think. Yeah, it didn't say Sunday, but you should include Sunday on Sunday or somewhere. Yeah. Anyway, so this is 17.5, and then alcohol on Sunday is 16. Okay. Here, on Sunday, 17.5. Oh, this is Sunday is 16, and for alcohol and for ecstasy is 17.5. And similarly, for Wednesday, drug 1 is 33.5, drug 2 is 7.5. Okay, I'm just going to, this is how you report. Like by Wednesday, drug 1 user median report the number of the group size, and then median report for alcohol user, and then report the corresponding U test and the Z-score and the p-value. Okay, so this is about reporting the median. And in terms of linearity, as I just tested it there. Is it here? And it will also, we can go. So what for normality, it's still divided in terms of splitting. Okay, just want to make sure that. Okay, and then go analyze, and then go compare. Actually, go explore, and I'm going to select both of these. And we actually don't need these statistics at this time because we have everything. But I think I have to, because to be continued there. This is a normality plot with tests. Is something that we don't need a stem leaf test, so to make it easier for us. What it does is it provides the statistical test with a p-value, which is easier for us to make a decision. My personal habit is visually look if it's normal. For example, by QQ plot, or to check the skewness or kurtosis. These are all related to the normality. But this is a quick way or easy way. Like you see QQ plot are plotted. Okay, let's go up. Again, this should be reported by each group, since I've split the file. Okay, and see and start from here. And now the first drug and provides and it's 10. That's right, because each drug we have 10. And descriptives, we don't really need this now. This is the test of normality. This is what we want to see. So here, the significance is 0.02. What it means is it is significant. So we reject the null of normal, the null hypothesis that the distribution of the first drug, the depression level distribution is normal. We reject that because it's 0.02. Okay, that means it's not normal. Okay, so another one here would be alcohol. So drug 2, and same here. And now you see the second one, it is not violating the normality because the significance, the p-value is quite large. It's much larger than 0.05. So in this case, it is the normality is met in this case. However, altogether they are not. Okay, so basically these are some, and of course you can also take a look at the QQ plot. QQ plot is this may take a while to, basically it's the observed quantile and the theoretical quantile, compare if they should be aligned. Okay, and then you can also see from this box plot, and it can also tell you like how far, like for example, this way, and this is probably why it's not normal. We have very extreme values. Like this is the main part, and here you have this point, and here you have this point. Okay, so and based on these graphs, you can also tell that they are probably very far away from normal. To be normal, it has to be symmetrical, and it has to be this bell curve shape. Anyway, so these are the some of these ways we can check the normality.